as the question says, the angle between the resultant contact force and the normal force exerted by a body on the other side is called the angle of friction. Show that if lambda be the angle of friction and mu the coefficient of static friction, then lambda is less than equals to tan inverse mu. Now let us first draw the diagram for this question, in which we have a block of mass m. Let us suppose that the normal reaction N is applied upwards. We have a force mg downwards, an external force capital F applied on the block, a friction, that is the static friction small f applied here. So we are going to get a resultant contact force, let us say R. Now this is the angle lambda. So we can write from here that tan lambda is small f over n, marking it as equation number 1. Let us proceed ahead. We all know that F equals to mu n is the limiting friction, that is, this is the maximum value of the frictional force that will be applied on the block. So we can write it as limiting friction. If we look into this situation, then we can say that as we go on increasing F from 0 to more value, then small f will keep on increasing in order to its tendency to keep this block at relative motion 0 as compared to this surface. But as soon as this small f reaches the value of mu n, it stops here. That means that no further increment will take place in value of friction. We can also write that frictional force is always less than equals to mu n. So we can write that mu is greater than equals to F by n. Using the equation 1 and putting it into this equation, we get that mu is greater than equals to tan lambda. That is, tan lambda is less than equals to nu, giving us further that lambda is less than equals to tan inverse mu.